Get strong.
Hello guys and welcome to my channel The Bio Guru, where science becomes sick. In today's lesson I will be talking to you all about anaerobic respiration in yeast. Now before starting off with today's lesson, I highly recommend that you all check out my previous videos on respiration because all the topics under respiration are directly linked to one another. With that being said, let's proceed with today's lesson, which is anaerobic respiration in yeast. So, before starting today's lesson, I want you all to know that during anaerobic respiration in yeast, only glycolysis occurs in the cytoplasm or the cytosol of the cell. This means that other processes such as the link reaction, the Krebs cycle and oxidative phosphorylation do not occur. So if only glycolysis occurs during anaerobic respiration in yeast, it implies the fact that during anaerobic respiration in yeast, ATP is produced by substrate-linked phosphorylation only. Now you can understand what I just said even better if you check out my previous video on glycolysis, where I have clearly explained the entire mechanism of glycolysis and I have even elaborated on how ATP is produced by substrate-linked phosphorylation. Therefore, it would be highly useful to you if you could watch my previous video on glycolysis. Now that you know the basic facts about anaerobic respiration in yeast, let's move on to the core part of today's lesson. So the process of anaerobic respiration in yeast starts off with the decarboxylation of pyruvate, which is a product of glycolysis. Now I have explained the meaning of decarboxylation several times in my previous videos, but for convenience I will briefly tell you all what decarboxylation means. So as the name suggests, decarboxylation is the removal or the elimination of carbon from a compound, and decarboxylation of pyruvate in this case means that carbon is being removed from the pyruvate molecule. And whenever carbon atoms are removed, they cannot exist on their own, and therefore carbon will form carbon dioxide. So to repeat what I just said, the process of anaerobic respiration in yeast starts off with the decarboxylation of pyruvate, which results in the formation of carbon dioxide. Now the decarboxylation of pyruvate is catalyzed by a special enzyme which we call as pyruvate decarboxylase, and as its name suggests, it's the enzyme that is involved or that catalyzes the decarboxylation of pyruvate and is therefore called pyruvate decarboxylase. When pyruvate is decarboxylated, it forms a compound called ethanol. Now the role of ethanol in anaerobic respiration in yeast is to act as a hydrogen acceptor because ethanol accepts the hydrogen that is released by reduced NAD, which is also a product of glycolysis. Now if you remember your chemistry well, you should know that whenever a compound releases hydrogen, it is said to be oxidized. Therefore, when reduced NAD releases hydrogen, it becomes oxidized to form NAD. So in other words, we can say when reduced NAD releases hydrogen, NAD is regenerated. Now you might be wondering, why do we need to regenerate NAD? That is because if you remember, I mentioned in the beginning of the video that glycolysis is the only way to produce ATP during anaerobic respiration. Therefore, if NAD is not regenerated, then the cell will run out of its supply of NAD, which in turn will cause glycolysis to be inhibited. And if glycolysis stops, then ATP synthesis will also stop. Therefore, in order to avoid this, NAD is regenerated, which allows glycolysis to continue, and so ATP will also be continuously synthesized. Alright, so now that you know why the regeneration of NAD is necessary, let's move on to what happens to ethanol once it accepts the hydrogen released by reduced NAD. So looking back at chemistry again, whenever a compound gains or accepts hydrogen, it is said to be reduced, and ethanol is no exception to this rule. Therefore, when ethanol accepts the hydrogen from reduced NAD, it forms a compound, a familiar compound called ethanol. And this conversion of ethanol to ethanol is catalyzed by an enzyme called ethanol dehydrogenase. So to summarize whatever I just said, ethanol accepts hydrogen from reduced NAD, forming ethanol, and this conversion is catalyzed by ethanol dehydrogenase. So you must be knowing that ethanol is toxic if left to accumulate, and it can be harmful to the body in high concentrations. Therefore, in order to avoid the toxicity of ethanol, it is broken down in the liver by an enzyme called ethanol dehydrogenase. So that's basically it for anaerobic respiration in yeast. Let me give you all a brief summary of the entire process. So the process starts off when pyruvate, which is a product of glycolysis, undergoes decarboxylation to form ethanol, and the decarboxylation of pyruvate is catalyzed by an enzyme called pyruvate decarboxylase. In addition to that, the decarboxylation of pyruvate results in the formation of carbon dioxide. Ethanol acts as the hydrogen acceptor and accepts hydrogen from reduced NAD, which becomes oxidized to form NAD, allowing glycolysis to continue. When ethanol accepts hydrogen from reduced NAD, it becomes reduced to form ethanol, and this conversion from ethanol to ethanol is catalyzed by ethanol dehydrogenase. Ethanol can be toxic to the body if left to accumulate, and therefore, in order to avoid its harmful effects, ethanol is broken down in the liver by ethanol dehydrogenase. So that's it for today, guys. Hope you all perfected anaerobic respiration in yeast, and if you did, please make sure to like, share and subscribe to my channel for more fresh content. Thank you all for watching today's video, and I'll see you soon with another lesson. Bye.